Hi, this is Khai Lai's showcase of Project 2, uh, Project 3, task number 2, having the robot to do Q learning and learn wall following behaviors. I can tell you straight up right now that it doesn't work. I think it's either the way how I implemented the learning algorithm, or it could be a problem with the with my state space design choice or or the reward function because after the robot learned for 6 straight hours, it actually performed way worse compared to the manually defined policies that we had for the previous test. So I'll just go ahead and show you what I mean. So before I start, I'll go ahead and this is the Q table that I learned from doing Q learning with temporal difference for 6 hours. And as you can see, it is, and as you will see, it will perform pretty horribly. There's a lot of clashing around. Um, I kind of make a big mistake with my action space design since I also allow it to have uh, a reverse action. So that reverse action was very helpful early on because it actually helps the robot to recover itself every time the robot gets stuck. But after a while of learning, the robot discover a flashing behavior where if it stay a certain distance uh, to the left of a wall and flash around, and I mean move backward and forward continuously, it technically is still wall facing. So and it gets an infinite amount of positive rewards from doing so. So it causes an emergent flashing behavior that I did not expect. So I'll go ahead and run my run me bash script. So when you run this bash script with no argument, it will automatically pops up the gazebo environment and have the robot test the policy that it learned, store in this qtable.txt here. Go ahead and run that. So as you can see, the robot immediately start flashing around, trying to reverse itself. Okay, so right now it master orients its left side to face this wall right here, and is traveling straight along a bit. Here it touches this wall here, and I think it's going to try to orient itself so that the left side faces the wall, but it usually fails to do so. As you can see, there's a lot of flashing behavior back and forth as the robot try to rescue itself from a semi-stuck and undesirable position. Yeah, so it is failing to reverse. Okay, so it managed to get out of that awkward situation. So here it is trying to orient itself to face. So that its left side faces this wall right here. So it did learn some wall following behavior. Uh, well, technically, I shouldn't really say wall following, but more like wall facing. Because as you can see at this point right here, it start learning the flashing behavior. It start doing the flashy behavior that it learns that as long as it is a certain okay distance from the wall and move back and forth like this, it is technically still earning positive rewards from doing so. So it's not so incorporating in the reverse action actually causes more damage than I expected. So right now I can tell you that it doesn't really work. See, as a robot is flashing back and forth, trying to maximize on that on my badly designed reward function. So for the next task, task number 3, I think what I will do is that I'll go back and straight up just redesign everything from scratch. I'll redesign my state discretization choices, uh, change my reward function so it actually encourage wall following and not just wall facing. Why is it not moving? Oh, yeah, GG. Okay. So it actually encourages the robot to follow a wall instead of just facing the wall. And I'll remove the reverse action in my action space since it's encouraging all sort of weird unexpected behaviors. As you can see right here, we zoom in. The robot here is also again doing the flashing behavior since previously the left side was technically facing the wall, so it was still earning a lot of rewards from doing so. And this policy was learned after 6 hours of training using Q learning. And it performs way worse compared to my manually defined policy. So let me go ahead and showcase to you what I mean. So I'll change this back to TD and I'll rerun test command. So I'll cancel this, do run du project while following and test and the argument test. So if you run my script with no argument, it will pop up the user's function telling you what sort of command line argument to run and what it does. So I'll go ahead and have the robot use the policy that it learns. So since there's no qtable.text here, my program will automatically create a new qtable and initialize it with the manually defined Q values that I had for task number one, the previous task. So as you can see, it created the new Q table. And this manually defined Q table works much better compared to the one that it learned. As you can see, the robot is actually doing some wall following here. And it knows that it's too far away from the wall, at least the left side. So it tries to orient itself and move to the left. Here it detected a space in front of it and decides to reverse backward to help it turn easier, as you can see. So it's so weird that my manually defined P-table works better than the learn policies, even though I did have it learn using the manually defined Q-table. So it improved upon what is already kind of good, and it somehow make it even worse. So my theory right now is either my implementation of Q learning is wrong, or I just have a really bad reward function that after a while the reward function actually corrupted the learning and actually make it to do weird unexpected behavior. So I think I'm just gonna go and redesign almost everything for the next task. So as you can see, yeah, it doesn't really work. Go ahead and move this here. Oh my god. I think I throw away the robot by mistake. Okay, test. Go ahead and move the robot here and spins it around. Hold on. So the manually learn key table managed to clear this wall pretty well compared to the learn key table where the robot will literally start flashing around right here and never actually manage to turn. Yeah, it seems yeah. Yeah, so I'll do my best for the next task, but right now it doesn't work at all. Thank you for watching.